Let's continue. I like the vibe. I like the mood. I like everything. Let's get to work now. Here we have an object is pulled downwards until the tension in the spring is this. So let's just come here and see. So I want you to know that tension is a pulling force. So we have an object here. It is pulled downwards by weight. Weight is a force that always looks downwards. So it has a weight. So it's going to pull the string downwards, but the string has tension, and tension is a pulling force. So this string is not going to push the object down where it's already going. Instead, it will pull it back up. So we have tension facing that side. So now let's go and put it. So we have just calculated the weight. So let's draw what we call a free body diagram. If you want to see a free body diagram, is just show the forces. That's what we call a free body diagram. Just something which is going to show the forces. So we have weight. And we just found the weight to be 4.9 newtons. And then we've been told that it's going to be pulled until a tension equal to 6.5 newtons develops in the string. Now they're saying the object is then released. If it's released, it still has these things. Okay? So now they're saying because it is pulled and then it is released. Calculate the acceleration of the object immediately after it is released. So okay, when it was being pulled, there was somebody who was pulling with some force. But now it is released. And when it is released, the only thing left is the weight, okay? The only thing left is the weight, and then it has tension. So these are the only two forces acting on this object right now. Now they're saying calculate the acceleration. You do know when we are not in motion, there is only one formula which we did, which is acceleration. And it was the resultant force is equal to mass times acceleration. Newton's second law. Where is it? Here. You are saying it, right? So we're going to come and say, okay, resultant force is equal to mass times acceleration. Now what they want is acceleration. So we can say resultant force over mass is equal to acceleration. So now write it to say acceleration is equal to the resultant force over the mass. We're saying acceleration is going to be equal to, what is the resultant force now? Okay? What is the resultant force? All right, now let's put the thing. Okay? What is the resultant force here now? We are going to say, what we know is that when you have a force facing the right hand side, it is positive, and the force facing the left is negative, okay? And when you have a force facing up and down, the one facing up is positive and the one facing down is negative. So remember, resultant force you're actually going to add, but all negative forces will end up subtracting. So because the weight is facing down, it is negative, it will end up subtracting. So it's actually 6.5 newtons plus negative 4.9 newtons, okay? And this is all over the mass. And what is the mass of this object? We look for it here, 0.50. So it's going to be all over 0.50 kgs. Because resultant is actually adding the forces. So we can say that the acceleration is going to be 6.5 newtons minus 4.9 newtons. Please put units over 0.50 kgs. So we're now going to say 6.5 minus, we put a fraction, okay? Fraction, 6.5 minus 4.9 divided by 0.5. Divided by 0.5, we're going to get our acceleration as 3.2, and this is going to be meters per second. Okay, meters per second squared. So what is this? 3.2 meters per second squared. This is going to be our acceleration, and we are done. Let's keep going. Come on. Let's keep going. We are on this blah, blah, blah. Stuff is going on. Let's look for calculation. The car reaches maximum speed of this at a time of whatever. Okay, so that means the speed, we can just put it, maybe we'll use it somewhere. Vmax is 130. Okay, meters per second. And this will be at t equal to 6.5 seconds. Anyway, now they said calculate the what? Maximum momentum of the car. This is easy. Momentum is equal to mass times velocity. Where else did we see the word maximum? On speed. So momentum, we can say that maximum momentum is equal to mass times Vmax, maximum speed, okay? Which is equal to, what is the mass of this now thing? We have a car, 1,400 kgs. So it is equal to 1,400 kgs times Vmax. What is the max? It's 130, okay? Meters per second. And what are we going to get? So 1,400 times 130. It's going to be 182,000, and this is going to be kilograms meters per second. This is momentum. So it's going to be maximum momentum 182,000, and this is kilograms meters per second. You understand?